So again, you're putting X and Y into Desmos, straight into a table. Once you get it done, it should look like mine up here on the board. Okay, back to our notes really quickly. When we graph this, we will not be able to see the data points. Like if you look at Desmos right now, you should not be able to see any data points. We're going to fix that. So look at your table. Tell me, what is your lowest X value? 12. What's the highest? 25? Okay, so right down here on your notes, we want our X values to go from 12 to 25. 12 to 25. And we're going to step, or we're going to go up by 1. So our step is going to go up by 1. We okay on that? We understand that? Kind of like domain-ish. Okay. All right, and then our Y values. What's our lowest Y value? 185. And our highest, 614. Okay, and again, we're going to step by 1. Okay, and that needs to go up by 1. Okay, let's transfer that part to Desmos. So in Desmos, I need your eyes up here, make sure you're paying attention because this is new. There is a wrench in the top right-hand corner. Go ahead and press the wrench. And then the part that we were just working with is this bottom half here of the box. Don't worry about the top. So we're going to go ahead and edit these. So we said that we want X to go from, was it 12 to 25? Is that correct? 12 to 25? Yeah. Okay, and we're going to step by 1. And then our Y is going to go from 185, we said, to 614. Step by 1. So you're just editing those numbers. Now, you should see in the background, your scatter plot starts to show up because you've changed it so that you can see the correct X and Y values. With me on that part? Good, okay? Kind of helps to visually see it. Press the wrench again and it'll go away once you're done. Okay, so we're done with part A. Any questions before we move on to part B? Okay, part B, find the regression equation. Okay, so this is literally the equation for the line of best fit. And Desmos is going to tell you the R value as well. Kind of neat. So in this next box, so right under your table, go ahead and tap in there. Okay, it should say 2 right there because you're in the second line. And do you see the little, here, let me just go back to my notes. This guy right here. This is what we're putting in that line. Okay, so when you type Y1, it will automatically make this one a subscript, meaning it kind of makes it smaller. So when you type that in here, Y1, it should automatically make it a subscript. And then that little curly line, that is right above, yeah, right under the escape button on your keyboard. Okay, and then M at, okay, and then again with the 1, it should automatically make it a subscript for you. And then plus B. Okay, if those items do not show up underneath, I'll explain them in a second. If they don't show up, let me know, I'll come help you out. Anybody not getting those? Okay, so if you look at them, I wish I could like expand it and look at it a little bit better, but do you see R equals right there in that box? Okay, that is your R value. So So we've talked about R value for a couple days now. That is the R value of this problem. And then right down here where it says M equals and B equals, that's your slope and your y-intercept. So now we can write that equation. So our R value is 0.9493. Okay. Our equation is y equals, is it positive 29? Yeah. We'll round that to 0.7, just round to 1 decimal place. Minus 148.9. Okay, anybody not get those numbers? Like you got numbers, but they weren't those. If that ever happens to you, it all stems back to the numbers that you put in your table. So that's why I say make sure that those table numbers are set. Okay. So let's break this down. Let's talk about what does this actually mean in terms of this problem. So again, we're comparing the ice cream and the sunglasses. Ice cream sales increase or decrease? What'd you say? Increase, right? Because it's a positive slope. So they increase by $29.70 for every, how many sunglasses? 1. Right, when I talked about slope, right, I talked about rise over run. So if you don't have a denominator, add in 1 there. Okay, our R value. Okay, our R value was 0.9493. What does that tell us? What does that tell us? Yeah, it's strong. Or does this seem to imply? So I guess we should say yes there. Okay, so we kind of hit this before we started this problem, but does your R value imply that sunglasses make people want to buy ice cream? No, it does not. Okay, what is the factor that does? The weather. Okay, the weather will bring people to those shops or not. Right, what does your model predict for the amount of ice cream sales when 20 pairs of sunglasses are sold? So where are we going to plug in 20? You're alive out there? Hopefully you're thinking that. Okay, now could you use Desmos to help you? Yes. Okay, you could use Desmos. I'm going to go ahead and just plug it in here. I'm getting 445.1, which if you look at your scatter plot, it should look like your line crosses about 4055, 445.1. Okay, I know that was long, but the next one will go faster because you know what you're doing. Any questions for me? Okay, so I want you to try to do part A of number 2 all by yourself. But what you need to do is you need to go into Desmos and you need to scroll and see where it says X right here. Click the X so that it gets rid of that. Same thing up here. Click the X on your table. It'll delete it out and then you can add it a new one. Okay? Your next table should look like the one that's on the board when you get that done. That's not right. Yep. Yep. Okay, anybody have any issues with part A? I'm going to open the bridge back up here just in case you guys need to see those numbers. Just to check your work there.
Remember, so you have to do your small set size. So what's your small set size? What's that and what's your largest? Okay. So we're going to do the same thing for Y and then it's short, that's fine. Okay.
Okay, that's what you should have there on your paper. Once you've done it in Desmos.
Did you change your, did you feed it to Oh, I changed it. That's what it was. So we're going to change this and then it should show for you.
Anybody else not getting their scatter plot to show up okay? Everybody okay on this? I'm going to keep moving if everybody's okay. You good? Okay. Part B. What does the y-intercept tell you about the temperature and elevation? What did I always tell you about y-intercept? Has a x value of 0. Okay, so 0 feet up, the temperature is 65 degrees. That's what that 65 at the end of your equation means. Okay, let's do the slope. The temperature in Nevada, is it increasing or decreasing based on our slope? Decreasing, it's negative. Okay, and it's only decreasing by just a little bit. Okay, 0.0047 degrees. Every what? Every 1, or the denominator, every 1 foot. Okay, in part D, you're going to use your model or the equation that Desmos gave you to find the temperature when the elevation is 3,000. So 3,000 is going to be plugged in for which variable? X. How do I know that it's X? If you look at your table, right, your table tells you elevation is that top column, that's what, or that top row, that's what we use for X. So we'll plug in 3,000 for our equation. Don't remember what the answer is. $50.9? I get 50.9? Anybody else try it?
I didn't know.
Oh, you didn't put that here. Oh, yeah. What does the graph tell you? Okay, so 51.067 degrees. This is the one that's from the graph. So remember me telling you that the line of best fit isn't perfect? You guys remember that? Okay, so is this an underestimate or an overestimate based on the actual value? That's an underestimate. Okay. All right, last part here is dealing with the R value. The R value was negative 0.9048. What does that tell me? What does that tell me? Strong or weak? Strong, right? It's 0.9. It's pretty strong. Okay, but it's negative, right? It's negative. In terms of elevation and temperature, what does that mean? What does it mean that it's strong and negative in terms of elevation and temperature? Does the elevation affect the temperature? Yes. Right? Very closely, because it's strong, but it says it's negative. So what does that mean? The temperature goes down as the elevation goes up. Okay, think about, has anybody ever climbed a mountain in here? Okay, so the elevation probably got cooler because you went up. So we'll say temp, it's supposed to be a T. Temperature goes down as elevation goes up. Okay, last part. We talked about an outlier before. Do we have an outlier on our graph? Look at Desmos. Do we have an outlier? Is it one that looks kind of farther away from the line than the rest? Yeah. If you tap on it, you can click on it on your, it'll tell you what it is. Go ahead and record that there on your notes. 5625,48. So that one is just really weird. For some reason, the temperature was weirdly high. Right there. Okay, so there was maybe a pocket of warm air there. And so for interpret, you can just say temperature was high. And there are some practice problem. I know this is a long lesson, it's one of the longest. About 10 minutes. Okay, I want you to get started on that next problem, which is on your